When we look out into the night sky, we're really looking back in time. Every star we see is a message sent long ago, a photon traveling for years or centuries before reaching our eyes. But there is a limit to how far we can see. A boundary exists, the cosmic horizon. Beyond it, light has not had enough time in the history of the universe to reach us. This horizon is not a physical wall, but a distance defined by the speed of light and the age of the universe. It marks the edge of our observable cosmos. Everything beyond it still exists, but we can never see it, never measure it directly. It is the ultimate frontier of astronomy, where knowledge fades into mystery. The vanishing universe. The universe is expanding. Galaxies drift farther apart, carried along as space itself stretches. This expansion isn't slowing down, it's accelerating, driven by a mysterious force we call dark energy. The faster galaxies move away, the dimmer they become. And here's the startling truth. Beyond a certain distance, galaxies recede from us faster than light. Not because they're breaking cosmic speed limits, but because space itself expands between us at that rate. This means there are galaxies whose light will never reach us. They slip beyond our cosmic horizon, vanishing not because they stop shining, but because the universe expands faster than their light can travel. In time, even galaxies we can see today will fade from view, swallowed by the horizon. The cosmic horizon, then, is not fixed. It shifts as the universe grows older. With every passing moment, the visible universe shrinks in comparison to the whole. The question is, what happens to the information contained in those galaxies as they pass beyond our reach? Information's last stand in physics. There's a deep principle. Information cannot be destroyed. When matter burns, crumbles, or changes form, the information describing it persists in some way. It may scatter into the environment, but it doesn't vanish. This principle faced its most famous challenge with black holes. According to classical physics, anything falling into a black hole was lost forever. But quantum theory, led by Stephen Hawking's discovery of Hawking radiation, suggested black holes slowly evaporate. The paradox was simple. If a black hole disappears, does the information inside it disappear too? Most physicists now believe the answer is no. Somehow, in ways we still don't fully understand, the information must survive, encoded in radiation, or smeared across the event horizon, or preserved in a holographic form. Now imagine the cosmic horizon as a kind of universal event horizon. Galaxies pass beyond it, carrying untold amounts of information. If information truly cannot be destroyed, then where does it go? Does it remain encoded at the horizon? Does it echo back in subtle ways? Or does it vanish from our view, yet persist in the deeper structure of reality? Echoes of a lost cosmos. Some scientists speculate that the universe may be holographic at its core, that the three-dimensional world we experience is a projection of information encoded on a distant two-dimensional surface. This holographic principle emerged from string theory and black hole physics, and while it remains a hypothesis, it provides one possible answer. Maybe the information from beyond the horizon is not lost, but stored at the boundary itself, forever etched into the fabric of spacetime. Others look to gravitational waves for clues. These ripples in spacetime, first detected in 2015, carry information from violent events like black hole mergers across billions of light years. If echoes can reach us in this way, might there be even subtler signals encoded in the structure of spacetime? Whispers from beyond the horizon? The idea is speculative, but tantalizing. Perhaps we live in a universe where nothing is ever truly lost, where every photon, every particle, every detail of reality is preserved in ways we cannot yet decode. The multiverse connection, and then comes the most radical possibility, the multiverse. If eternal inflation is correct, Our universe may be just one bubble among countless others, each with its own laws of physics. In this view, the cosmic horizon doesn't mark the end of everything. It marks the edge of our bubble. Beyond it may lie other regions of space expanding away, unreachable yet real. Could information flow between these universes? Could faint echoes of other worlds influence ours in ways too subtle to detect? No evidence yet exists, but the theory reminds us that our horizon may not be the final boundary of existence, but only the limit of our vision. It is humbling to think that what we call the universe may be only a small piece of a much larger reality. Beyond our grasp in the end, the cosmic horizon forces us to confront the limits of knowledge. Physics suggests that information cannot be destroyed, yet the horizon hides vast stretches of reality forever beyond our reach. Are those galaxies still part of our story? Or do they belong only to themselves, exiled beyond the possibility of contact? Philosophically, it raises questions about what it means to know the universe. Do we live in a cosmos we can never fully describe? Does reality extend into infinite realms we can only imagine but never measure? Science thrives on testable theories, and here we approach the edge of what can be tested. Still, the pursuit matters. The horizon reminds us of our place in a vast and unknowable universe. It is a boundary not only of light but of human understanding. And yet, that is what makes it so captivating. To stand at the edge of knowledge, to ask what lies beyond, is to be human. Whether information echoes back to us, whether the universe is holographic, whether multiverses exist, these questions may remain unanswered. But in seeking them, we expand the horizon of our imagination, if not our sight. The cosmic horizon is not the end of the universe. It is the end of what we can see. Beyond it lie galaxies, stars, and perhaps even entire universes, forever beyond our reach. Yet their existence changes us. They remind us that reality is bigger than our senses, deeper than our theories, and more mysterious than we dared to dream. So the next time you look at the night sky, remember, you are not just looking at stars. You are gazing toward the edge of knowledge, the boundary of the observable, the horizon beyond which echoes may still exist. And that horizon, though unreachable, continues to shape the greatest questions we ask about the cosmos.